which is a firm that from its very inception has been concerned with the intersection of technology and engineering with art and architecture. To quote the founding partner, Sir Edmund Happold, "A world which sees art and engineering as divided is not seeing the world as a whole. It is technology that is creative because it gives us new opportunities." The firm has been very much at the forefront of the intersection of engineering and architecture and has consulted on such projects as the Millennium Dome in London and the glass roof on the British Museum with Foster & Partners. The firm consults on a multidisciplinary array of technology applications for designers spanning structural, mechanical, geotechnical, lighting, facade, sustainability, and does these things at the three scales of the building, the city, the building, infrastructure, and the city. Craig Schwitter holds both bachelor's and master's degrees in engineering from Johns Hopkins and MIT respectively. He has worked on numerous sustainable buildings and planning projects in both the United States and the United Kingdom, and has lectured on sustainability, integrated design, and innovation of engineering. In 2000, he founded the first North American office of Buro Happold, and under his leadership as managing director for North America, the firm has expanded across the US to major metropolitan areas and now has 200 employees. His focus is on integrated engineering with a special emphasis on low carbon and high performance design building issues. In 2001, he was appointed the first Bedford Distinguished Chair of Architecture and Engineering in the Architectural and Civil Engineering departments of RPI. Recent projects that the firm has undertaken out of the US office include the High Line in New York, the RPI Experimental Media Performing Arts Center, the Visitor Center at the World Trade Center Memorial, and the Walton Museum in Bentonville, Arkansas. And he wouldn't let me mention any of the awards that the firm has won, but I think it's important to note that in the last year alone, the US operation of Buro Happold has been recognized for engineering excellence across a series of fora that stretch from lighting design to the American Institute for Steel to the Royal Institute of British Architects. So, welcome.
That was great. Thank you very much. That's a little embarrassing, all that stuff. But anyway, I'm here to talk about the work that I do and the work that my firm does. I'm an engineer. I like being an engineer. Just want to make sure everybody knows that in the room. But I am used to being surrounded by architects, but I have, after about 20 years, managed to befriend most of them and have good working and collaborative relationships. I want to talk today just really what's on my mind after half my career really at Buro Happold. It's been a great place. I've grown as a structural engineer into doing infrastructure and at the moment doing city scale type work. And I wanted to really show this type of connection that we see as a firm between different scales of projects between 1, 10, and 100. I continue to see the world as a very connected place, and solutions and strategies and value to be part of that kind of connectivity between these issues. So just to kind of riff on the theme, and really the biggest issue is curing our environment. Our environment is dying. It's being killed by us, by design, by intentional things that we do and we've been doing for many years. And we have to stop. And I just want to try and show some of the ways I think that we can start stopping that and hopefully correct the course. My firm is global, which is a benefit for me because I get to work in both, shall we say, Western markets or shrinking markets and emerging markets or growing markets. We work in places like India where you're putting up a building every other second. We work in places like Detroit where we're actually working to restructure infrastructure there to actually re-densify the core of the city. Very, very different types of problems. But we do have offices here in the United States, which is where I tend to operate, but I live in New York, but I also work from New York and Los Angeles on lots of projects around the world with great collaborators. And this is just a kind of a hodgepodge of some of the stuff that we've done. I've been involved in things like the Millennium Dome, stadiums, cities, new cities. This is, as you might do, 60 million square feet in the desert in Saudi Arabia. The Louvre Museum in Abu Dhabi. Also been, as my career has evolved, I've been very interested in structural technologies and lightweight structures, but that idea of lightweight systems and touching the earth lightly has kind of evolved for me. And it's evolved in large part due to what Ted said as a culture in our practice. Ted passed away in 1996. I was really lucky as a graduate engineer to get to know him and share some, he used to drink these Bucks Fizz things and just, you know, he'd give you a book and say, you know, read this book on Jean Prouvé, and he was great. But he had this idea that there's a bigger picture out there. Even if you're an engineer designing a beam or an HVAC system or lighting or a road network or sewer or, you know, street grid or planning, you know, for carbon reductions, there's a bigger picture. And this is something I go back to virtually every day when I'm thinking about it. How are the things that I'm doing today impacting things, impacting people? And this is the issue. I mean, you know, the carbon footprint is everywhere. It's, you know, it's amazing. I travel a lot, and it's on the tip of everybody's tongues everywhere, except for the United States, where we're somehow politically putting our heads in the sand yet again and thinking that carbon as a problem doesn't somehow exist. But it does, and we'll get through this nonsense and realize that we actually lost a couple of years of really good productivity to actually solve this problem. But I'm going to come back again to this problem because global carbon is the problem. We are killing ourselves, okay? It's amazing that architects and professionals get trained about life safety, about corridor widths, but you don't get trained about energy. You know, how many tests are you taking about building energy? And if you don't get your energy down in buildings, well, we're all going to kill ourselves. So what other life safety issue is there aside from solving this problem? I don't want to be such a sort of a one-trick pony on this one, but you know, guys, we got probably 30 to 50 years to solve this thing before the tipping point happens. And you know, I don't have to tell you of all this, you know, what goes on. You just read the New York Times, or I really like Thomas Friedman. He always sort of ties it into geopolitics. I really like this author, Paul Hawken, as well, who is very interesting about design and the rationale and the value behind pieces. And this just drives me nuts because we've designed these things. This is intentional. This didn't come from anywhere. Somebody intentionally made that road, designed that transportation system, designed this landfill system. These are intentional things that we're doing that are so wasteful that it's shocking. And we have the power in all of us, everybody in this room, our next generation, to change some of these things. But I guess my question is how? And I'm not one of these people who are going to wrap my hand around a tree and say, you know, it's all moral. It's not, actually. What I am and what makes me tick and what I'm interested in is the value. Why isn't sustainability or other elements of this valued in a proper way? Because I think when you unlock the economics of these problems, you unlock the strategies, the rest will start to follow in a little bit of an easier fashion. I won't have to be convincing that developer that this is the right way of doing a net zero project. You know, it will be something that they have to do. And I'll start to show some of the strategies, but just to emphasize, it's about design. These are conscious choices that we're making, many in the wrong direction. And again, the challenge, I put this up in Mandarin because for some reason our Chinese clients in Beijing and other places are more interested in this problem, which is quite astonishing. But anyway, this is the basic issue is limiting climate increase between 2030 and 2050 by 2 degrees. There's a lot of statistics and data out there. You can go and read TED Talks and all the rest of it, but that's basically it. And there's a couple of different strategies to get there. I'm not going to go through those strategies. You can read them on your own, but this is a kind of an overarching problem and a challenge that we see. Now, some background here. Hopefully, everybody knows this, but I'll just repeat it, just in case you don't know, that buildings take up the most important area in carbon. Okay, buildings take up between 40 and 50% of carbon emissions in the United States. It gets worse, because if you're in a dense urban environment, 75 to 80% of your carbon's coming from buildings. Because you've actually already optimized your transportation networks, and your industry is starting to move out, or has moved out, or is a smaller footprint. So if you're looking at dense population centers like New York, who set carbon limits in 30 years for 2030 challenge, sorry, not 30 years, 18 years from now, this is a major issue. What are you going to take, 75% of the buildings away in New York City? I mean, it is a very difficult, knotty problem. And this is, just to give you a sense, residential and commercial kind of quads or energy or big units of energy, but just showing where sort of energy goes in buildings. Cooling, refrigeration, electronics, office equipment, water heating, lighting. Lighting actually jumps out at you here, especially in the commercial area. At almost a quarter of our energy goes into lighting in buildings. And another element to really understand, and this is particular to the US marketplace, that buildings have 70% of our electrical consumption. Yeah, that's an important factor. So buildings drive electricity consumption. Electricity, primary electricity is developed by coal in the United States. And that's a big issue in terms of looking and unlocking strategies for energy reductions in buildings. So, how does the market respond to all this stuff? Again, I'm a market guy. I'm not a Republican, thank God, but I do believe that we have to find these economic linkages to solve these problems. And the market is pushing. I mean, LEED has done a tremendous amount, and there's all kinds of other systems around the world. If everybody thinks that LEED is the only one, it's not. BREEAM and actually this is Estidama in the Middle East, all actually very aggressive. And one of the nice things about these systems is they're setting benchmarks and consistently lowering the benchmarks. This is actually just simply regulation, which is good. I was at a conference a couple of weeks ago with the ex-director, Kyle Browner, of the EPA, and we were talking about regulation. And it's amazing how regulation is seen as a bad thing right now. But regulation for this problem is necessary. LEED is important. When Boston says all buildings will be silver LEED, and LEED then reduces the energy benchmark the next year, all buildings in Boston in the future just got more energy efficient, under the radar screen. No politics at all. So this is a very important issue about how the market's responding. This is about LEED all around the world, which is really great because LEED has become a brand, not just something to achieve. Most of our clients, I mean, I haven't done a non-LEED building in a couple of years. I mean, we don't do non-LEED buildings. I mean, I'm not quite sure who does them. So, I mean, even if you don't get that LEED rating, you can just get it with normal construction technologies. So, and by the way, if anybody tells you that a sustainable building is more expensive than a non-sustainable building, tell them to go shove it, okay? Because that's not true. It's the designers and the quality of designers that actually make that expensive or not expensive in terms of delivering a good product. And this is why, because the market is moving clearly in this direction. There's a big, typical building practices are now really shoving themselves down. I've seen it in sort of 10 years, and this is a really positive aspect of it. Other elements that are on the good side, benchmarking is starting to make its way through. This is all about how the market and governments are responding. New York City has leading laws in the United States on benchmarking for buildings, which means that in New York City, you have to inspect your buildings every 5 years for bricks so that your bricks don't fall off your buildings. But you never had to audit your energy. In fact, nowhere in the United States you have to audit your energy. Not in Syracuse, not in Chicago, but New York City has just started an energy auditing program. So within 5 years, every building will be audited for energy use. You'll be able to look at that on the internet. San Francisco's moving that way, et cetera. And when carbon capping comes into play, then those owners that have very poor performing buildings are going to start worrying that they have very poor performing buildings. So it's starting, which is very good. In the wider world, you've got a whole series of things. I would say that the USA is behind, but on a state level, it's actually pretty ahead. But on a federal level, it's behind. But UK, France, China actually has some very stringent legally binding carbon limits coming up next year. That's exactly why we're doing a lot of work in China right now on low emissions and low carbon development. And companies are, corporations, as evil as they may be from the Zuccotti Park point of view, are actually following suit, and they're trimming their sails, and they're doing the right things. We work with Marks and Spencers in the UK. We work with some companies in the US, and they see it maybe a slightly different way, but they're looking at these issues. The Carbon Disclosure Project, which is a very large project for Fortune 500 companies to invest in to actually disclose their carbon use, is an important area. And I think different people, and we work with different types of client types, are seeing this problem and trying to get ready for what's coming in 5 to 10 years. The market's also responding, interesting, that people want this product. I was at another conference recently talking to some developers, and they were agreeing, and this was a pretty old dyed-in-the-wool New York developer, agreeing that there was a new value proposition out there for development. He still thought that nobody would really, that 80% of the market wasn't paying for it in New York City, but he also agreed that there's certain areas, and this is rents in Battery Park City looking at higher rents for more sustainable or green type buildings or improved air quality. These are all also issues that I'm very interested in, these types of metrics where buildings have, or infrastructure, elements of infrastructure improving quality, because the value behind these pieces, as I'll go into it, can really unlock why you want to be doing these things, why you don't just want to be doing BAU, business as usual. And I'll get to this a little later, again, about health and productivity, but health is key, and productivity is key to unlocking some of these value equations. This just shows, in general, where some studies show reduced respiratory potential U.S. annual savings could be in the billions in terms of healthcare costs with trimming down sick building syndrome and things of that nature related to poor building quality. So, and this goes through my mind in terms of how to quantify this. I mean, I'm an engineer, I want to quantify everything, but and in that I want to use that quantification to somehow solve potentially a qualitative problem, and that's very difficult. But I do think these areas of reduced glare, how do you quantify a student want to go into a class? How do you quantify being connected to nature, biophilic or biophilia type of measures in buildings? And we've seen this. There are some specific studies. This is a study in views in terms of call center productivity. I mean, this is kind of common sense, and yet people still don't believe it. So, when somebody is actually by a window, they're just more productive. I mean, it's just simple. I mean, retail, when you have access to natural daylight, you buy more. These are elements of understanding how buildings make us sick and could make us healthier or more productive. What kind of environment do we choose to live in? What kind of environment do we choose to design? Other issues of daylight retrofits. Daylighting, again, is huge. We have a lighting group that's now about 8 people, came from nowhere about 5 years ago, and they do almost half their work is all natural daylighting, not electric daylighting. How do you design buildings for zero electric light? That's actually coming pretty quickly in terms of an office building which has only natural daylight inside of it. And again, linking to productivity, but I'll get into this a little bit later. So I wanted to talk a little bit about strategies at a 1, at a 10, and 100 level, just to sort of scale up as we go along. And the first is at buildings, and this is my first observation on buildings. We've moved, I would say, in my short career, from sort of the mid-90s to now, we've moved from the building environment being about materials to being about energy and performance. I mean, I used to go to interviews and be like, what do you think about the size of the foundations or the weight of the steel? Should it be a steel or concrete building? And we go to the same interview now when we're doing mechanical and structural, and we don't get a structural question. I mean, we get, what about LEED? Does it cost more? Are carbon taxes coming? What about the HVAC systems? Is lighting, can I reduce my bills? I mean, these are the types of things that we talk to university presidents on, CEOs. This is what they're interested in. I haven't had a CEO or a university president ask me a structures question in 10 years. They just, I'm not quite sure exactly the overall phenomena, but I do know it's moving from materials to this. It's moving, we are understanding that buildings are, and our environments are about performance somehow. And it's just a very, it's sort of implicit, and yet it's also not implicit. This tries to show what I'm talking about. When you're building a building, if this is the original cost of your building. Above the line here, your capital costs you're building. So once you finish, you're sort of in this land. Once you operate the building over a 30-year time period, you have maintenance and energy and furniture depreciation, building maintenance, these kinds of things. So without staff cost, this is without staff costs. So this is a office building, this over 30 years. You're building, say, a 300,000 square foot building. You're putting, 1,500 employees in it. And this is the kind of model that you see. But this is what happens. After 30 years, that employer actually spends this much amount of money on the staff in the building. We just started a building, a $400 million building in Pittsburgh for PNC. And at the opening, I said to the well, he was the CEO, he's the head of real estate. He said, $400 million, it's a lot of money. I said, you're spending $4 billion, He says, what are you talking about? The price just went up? And I said, no. Over 30 years, PNC's spending $4 billion in Pittsburgh. That's what you're spending. You're not spending $400 million. That might be our budget, and you might have operating costs. And this basic fact is for, you can go for any office building, any building that people work in. It's the value of the people inside that's important, not the value of those bricks and mortar. And this is the graph, if you want to do the numbers. It looks pretty scary. This is actually, initial construction costs. You look at MEP and even when you quote unquote have green construction costs on top of some of these things. But actually, this is what it looks like when you factor in that productivity angle. And so, people, it's not like I've invented this out of scratch. People believe this. CEOs believe this. I believe this. When I renovated our office, I wanted to do it well because I want people to be there, stay there, be healthy, have good indoor air quality, like the place. So but this is a project we did in Boston where these strategies really played out. We had this is probably about 2000 timeframe, 2001. Stefan Banish was the architect. He had a lot of these strategies integrated with his architecture, but he did a very good job at explaining them to the CEO at the time. And the interior of the building, it's interesting. This was a spec office development initially, which turned into a development that Genzyme fully bought out, and the developers were happy as Larry because they got to make a lot of money off of it. But the one interesting thing about it is we have a central atrium cut through the building that actually has a very innovative lighting system. We didn't design this. This was by a German firm, Bartenbach, who are fantastic lighting designers. And one of the things about this building is it has great natural daylight all day long. It's a 14-story building, so normally you wouldn't get that type of daylight penetration, but you get very good daylight penetration in the building. And so, Henry Termier, who was the CEO, got this whole equation. He said, what is my upcharge for actually investing in something that will have better lighting, will have better indoor air quality, will achieve these types of issues? And, this ended up being the product. This is just looking through the atrium. One of the things that Genzyme wanted to do is connect it into the street. So Genzyme had a problem in terms of public perception, so you can just walk right into the building, right off the street. These chandeliers look a little funky, but they're all part of this daylight enhancement system, which actually takes light from a series of mirrors, these mirrors, and actually directs it through prisms down into the body of the building. So any conference room, basically you get natural daylight in any conference room all day long throughout the building. So this is the type of building that you see inside. So, and just is showing a kind of a cross-section. So just a new interpretation of basically, you know, an atrium type building, some of the images of these. So, and this is what Genzyme saw. And what we've proved. The building's been operating about 5 years. We keep in close touch with Genzyme, and we've monitored a number of times, and they feel like it's already paid back within a 5-year time period, and they have a 25-year lease going on a building. They're very happy. Genzyme's very happy. Second issue, net zero, in terms of it becoming reality. I think we as engineers see all the issues associated with this being very difficult, of get absolutely zero emissions on a building, and also you can talk about how boundaries are potentially fictional on what is net zero. But in any event, I think that we are approaching that issue. For those of you who don't know, living building challenge is above, well, not above, but probably more aggressive than LEED. We've done one of the first living building challenge projects, which is this project I'll show, which actually requires you to monitor the building for a year and have it net zero. So this is a preparatory academy that we finished in Hawaii about 2 years ago, and their slogan is no credits, just prerequisites. Living building challenge is about net zero. And this is a site, I mean, it's a great site. It's a site that you can make net zero work. It was a great client, a client that you can make net zero work on too. So those are good starting points. I'll be the first to admit it. But you know, it was an interesting project nonetheless. Starts with a sketch, starts with really understanding how a naturally ventilated building would work, trying to get the energy as low as possible. We did fairly extensive modeling to look at the prevalent wind patterns, to make sure that we were getting the right type of air distribution inside and ventilation patterns. And this is the end product. And it's a great space, and the client's very happy with the building. It's a multi-age preparatory academy. And you know, this is part of the issue about all these things go into your energy in a building. So your initial demand of the building, this is the strategy for any net zero. If you're ever going to do a net zero building, hopefully all of you will within a short period of time, is you have to move to look at what your CBEX or your average energy take would be and reduce that. So look to reduce demand. You can't make net zero work with just increased demand. So look to reduce demand to a point where you can balance it with renewables. Normally, this is 50-50. Normally, the strategy that we try and take is 60 to 70% reduction of energy and 30% uplift for renewables will get you to about that balance point. So renewables being actually, and renewables are not just geothermal heat pumps, renewables are actually producing energy on site, which is kind of tough. Photovoltaics, wind, and that can be actually very expensive and inefficient in city environments. So that's a real challenge going forward to figure this out. But interesting enough, these green bars are the actual Energy Lab electrical consumption, and the gray bars are how much they produce on site through a wind turbine and photovoltaics. These guys are killing it. They're actually really tuning their building and using it. We thought that these are the summer months. We thought, oh, you know, we have to design in the capacity into the renewables because, you know, they're not going to use the building properly. We'll see a degradation. No, they blew us away. They're using it really well. Now, this is every client I wish was like this personally, but they've just been fantastic. And you know, they've done these surveys about the building, but you know, both kids and parents, and you know, this issue about liking that environment. This is a great environment. It's a well-designed environment. You know. So it's just the statistics are playing back what we know, but it's nice to have that in play. Third theme here, simulation. We love simulation as engineers because we get to play with computers because, you know, that's what we like, and we get to kind of like, you know, it's a filter for data, but simulation is really going real time. I mean, I think one of the major issues in MEP and energy engineering is just simply simulation. The tools and the computers are so much faster. We could do modeling in a fraction of the time that it used to take us even 3 years ago. So that is really changing the design process. The tools are just coming, I think, at the right time. still a little crude. We still have to kind of garage sell them together and tape them together with duct tape and things like that to get them all to work. But you know, thermal and energy modeling is key. You know, I don't know how many of you have even heard of thermal or if you've done any work in your classes. You should know about it. You should start understanding what it is. You should start getting familiar with programs. Ecotech does very simple pieces on this. Every one of you in this room is responsible for this, not your engineer, all right? Every one of you is responsible for having an intuitive understanding of how to design. I'll help you. I'll check it. But I tell you what, I get really pissed off when I'm working with an architect who doesn't know what they're doing. It just makes me mad. You know, it's not to say I don't make money off of it, I do. You know, I'm a consultant. But I'd rather actually work with somebody who knows what they're doing, like Stefan Banish, because you can go so much farther and you can make so much more of an impact. You know, this is a big issue. And I really want to make sure people understand this. They're not afraid of these tools. One of the things that we're trying to do is develop tools that allow you as a designer or a lead designer to play, to actually, you know, almost like a video game, to play with these tools. Not to like make it like DOE2 and like, oh my God, this is a black box, I don't know what about these numbers, but actually like what happens if the building turns and does the energy go down or up, or almost gaming it to the extent of understanding those intuitions. CFD is more complicated. I don't expect people here to do CFD. That's computational fluid dynamics, but it's very important for thermal movements of airflow, ventilation, things of that nature. This is just you know, models that we do, you know, pretty much day in, day out on various projects. These used to be models that you would do a kind of a crazy design and then send it off to some computational expert somewhere in Canada and get it checked. You know, we do it now real time. You know, not like that minute, but we do it within a day. And I think this idea of that feedback loop, it's not we're checking it anymore. It's not that I've just over-designed the MEP systems and I have to check it to make sure that I'm not going to get sued. You know, I actually am able to use these tools to actually right-size the systems right there. Capturing light is really important for simulation as well. Daylighting, as I showed you earlier, lighting is like a quarter to maybe even more in terms of the footprint of energy at a building. And this is critical. A lot of great lighting tools out there, and I mentioned about daylight before. And how all of these things go about, and they start mashing and forming the earliest stages of a design of a building. This is a tower that we've been investigating in Pittsburgh, this PNC Headquarters project, and just looking at different aspects of orientation on this. And this is not the tower, but this is the software that we've been developing, which is at the earliest stages. We're not waiting until 6 months down the road or somebody has this perfect like Chippendale kind of tower, and then they say like, what's the energy performance on that? You know, which has which has each side of the box the same facade type, which I've never understood. And no, we're trying to say at the early stages, what happens if we twist? What happens if we make it taller? We thin it out? What kind of orientation? What kind of spatial issues are there? What kind of issues are there in terms of the energy performance that you can do for virtually no money up front that can save you huge amounts of energy impact? These are the types of tools I said that we're putting together with duct tape right now that are really tough. These are the energy profiles and the carbon counts that we're getting from these different types of design moves. We're trying to do this almost in real time for the architects that we're working with. I'd say almost. This is probably like half a day type turnaround stuff. You know, where you know, we might have a charrette, we might be there for, you know, multi-day working charrette. You know, somebody will take 3 or 4 options of looking at different buildings. We'll analyze them overnight. We'll bring it back for the next day, and we'll start playing around with it again. So we want to, and I think within a year we'll probably get this to the point where you can actually just sort of manipulate it almost real time. Do you have a question? Yeah. Okay. No, you can ask it now. I don't mind. Yeah, yeah. Well, you can. You can. I mean, we know where the sun is normally, so yeah, we can, and we know that we want to make, you know, normally southern exposures longer. I would say the best tool use is actually taking intuition and pushing it further, not just kind of shotgunning it, or monkeys in a room trying to type Shakespeare. I would say it's following that kind of thread of intuition. So, we know basically for site orientation, wind orientation, what we should be looking at bracketing. But I'll tell you, sometimes the modeling does show interesting things. We did a building, we're doing a huge building in Abu Dhabi. It turns out, and we had fins on the north side of the building. We said, well, there's nothing on the north side, right? It's still, we're not getting energy input there. But the models were actually telling us we were. And it turns out that we were getting some sun in at the earliest stages of the day and the night, even on the north facade, which was not, didn't have intuition to us. And actually, we had to change the glazing design because the building skins are so sensitive in that part of the world to performance. So I would say, I would say it's not that computer programs are smarter than us, but they do sometimes give you some anti-intuitive directions, which I think is what they're really meant for. Also realize that the numbers we're getting out here are just estimates. We actually, I'll go into EUI, but we like to call these predicted, values, not because we never like to be pinned down on anything as an engineer. But yeah, it's got to have a factor of safety built in somewhere. But these are just looking at glazing ratios and trying to understand how that affect, again, simulation type of things in real time. And these types of graphs looking at these kind of crossover inflection points, looking at what kind of sweet spots we might see in the design. So you'll see these types of graphs come up again and again. But they tend to be strategies from here, which is one option, all the way down a kind of pathway. And one of the interesting things also about energy use here, you ever see the film Apollo 13? When he's trying to get like the energy low and he's like doing this one and that one. Actually, it sometimes depends on the order that you do them in. Like they're not all additive. In other words, if you take underfloor air and then you add ventilation, then you change the orientation of the building, and then you use a solar chimney, and then but if you change the order around, we sometimes get different numbers. Now that might be a fault in our modeling, but we don't think so. We think it's actually that there's something about the order of what you do, and the strategies sometimes get you to lower numbers. So we'll see. We haven't gotten to the moon yet, but hopefully we'll get there. This is I'll leave this and we'll jump up to the next scale. But this is now on the back side of what we're doing is actually disturbing. Because as we're looking for computation, energy efficiency, and all these other things, there's a difference between energy intensity and energy efficiency. Okay? Now, I know you're going to hate me. This is an equation, but this is something you should all know. If anybody doesn't know it here, please remember one thing from my lecture, what EUI is. Energy use intensity. It's miles per gallon for buildings. You need to know this. You need to know what your miles per gallon for building of every building that you will do going forward in your lifetime. Please, promise me one thing from tonight, okay? Because this is really important. This is a simple but a key metric for measuring building energy use. And the problem, well, I won't get to the problem yet, but this is just to give you a sense of metrics. 90 is about the typical EUI factor for a building. A building at 30 is very, very low. Different buildings have different types of profiles. So a healthcare building will have a very high energy use intensity, which makes sense, and an education building will have a lower one. So just to put that. But this is a project that we did for 6 million square feet in New York. It was a developer trying to reposition their assets, Trinity Real Estate Holdings. They own this whole series of older buildings around Trinity Square. This is the Holland Tunnel right here. And they had a lot of buildings that are Class B or Class C. They're older buildings, casement windows. And you walk into these things, and it was like, the wind was blowing in them, and the steam was overheating. I mean, you were like, this is easy. I mean, we're gonna move in with some energy efficiency measures. We're gonna nail this thing. We're gonna have the happiest client ever. So we did this, and it was a series of buildings. We did a number of energy audits, and we found a really interesting statistic. because they had different buildings in different stages of development. They had some buildings that were in stages of development that were brand new and had like media companies coming into it. And they had buildings that were older, and they had sort of older, sort of law firms or things like that in them. And it turns out that if this is the sort of existing energy use, projected energy use, and benchmarks, it looked, from us, was quite amazing. After we did or projected to do energy improvements, the energy uses all went up in the buildings. Up. They didn't go down. I mean, the client hauled me in by the collar and said, "What the hell are you doing? You're putting in, lighting upgrades and HVAC upgrades, and this is what I'm getting." I told the mayor that we were going to go down on carbon use, not up. He called me a couple of things, and I said, well, the issue here is that actually the new companies, the projected energy intensity of those companies is higher. It turns out, even if we do the energy efficiency upgrades, the new media people coming in are actually using more power. They're using more plug loads. They're using more computers. They're using more lighting and office equipment. So this is a really tough nut, because it's probably something out of my sphere of influence to do, but it goes down to behavior and also technology pieces. Getting that energy use, the demand down, is going to actually require a lot of behavioral instinct changes from clients. Because if we want to see it going the opposite way, we have to make sure that we are actually tuning, we have to take lighting levels down, we have to take energy plug loads down. What often happens is you'll do your rent lease and you'll require a certain energy density for that floor. And that energy density will be huge even though you don't use it. So what does that building do? They have to build the infrastructure to deliver that power. And that power sometimes is used when it doesn't need to be used. And we need to think about how to solve that problem, because personally, we're fighting this, and this is my office. And we're tracking our energy use, and our energy use is going up. So we're part of the problem too. And this is a tricky thing to solve. Remember, energy efficiency is not always equal energy intensity. And in fact, what we're seeing is sometimes that these things are opposite. So getting that energy use intensity down, like some projects are, like the NREL labs and other types of really great projects that are out there, just released, are doing it from a lot of behavioral change within their buildings. A scary statistic is one of the quote-unquote greenest buildings in New York City, the Bank of America, has an EUI off that chart. It's a platinum building, and it wouldn't be, that green chart wouldn't be on that chart. So that's a problem, that what we're saying is not always what we're delivering. And that energy intensity piece is a part of it. I'm looking for somebody in this room to help me solve it. Onto infrastructure, energy supply and smarter grids. This is just looking at how, pretty simply stated, we have transmission and we have demand. And this is how it works right now. But we really need to think about this in terms of, again, bringing that energy demand down, because actually what happens is your power is developed here and your power is delivered here, but it's very inefficient to get from one to the other. And so these power plants, 100 to 1,000 megawatt type power plants, are coming through grids that are extremely inefficient. And we have done a number of projects that look to distributed grids. New York City has a plan to put in more. I'll show you a little bit more cogeneration. But this is something that's happening a lot in developing countries, less in the United States. And the reason why is that 100 contents of energy at a coal plant ends up at 30 at your house. There's 60%, over 60% of the energy is lost at the power plant and in the transmissions that get to your house at coal. Natural gas is better. It's a lot more efficient. But coal, which drives, remember that electricity piece that I was talking about earlier? This is a real problem, So the grid, I mean, again, this is not something that you can deal with at a building scale. Now I'm sort of scaling up. When we're talking about maybe developments or areas of cities, we really want to start to look to more distributed energy generation. Cogeneration is interesting, and cogeneration is just developing and burning and creating energy at source. So you could have a cogeneration plant, a 4-megawatt plant that actually generates and delivers power to your building. Think about how much more efficient that is than buying that power from that coal plant, 500 miles away. The utility companies do not want you to do this. They do not want you to be generating that type of electricity. It's going to put them out of business. So, and this is a problem. I mean, because utility companies are a real obstacle, honestly, to this type of energy efficiency piece. But it's as clear as day about what the solutions are. It's pretty rare that we get to put cogeneration into buildings right now with our clients in the United States because of the economics. Because that energy generation is so cheap at source that doesn't make any sense. It's more expensive to do it at the building source. Even though it's more efficient, it's more expensive. This goes back to that value piece and regulations. If it's cheaper to burn coal with no regulation, then that cogeneration is never going to happen. And then that cogeneration is never going to happen. We're always going to be in an inefficient spiral on the grid. That's the basics of the grid. I'm no grid expert, but that's the basics of what we see in terms of looking at it from distributed generation source. Looking to carbon reductions more broadly at infrastructure scales, there are some very good initiatives going on. Cap and trade, although it's kind of in the background, a little hidden right now, but I think it will rear its head again. California just announced a very interesting cap and trade, I think 2 weeks ago. But again, these are the type of business as usual curbs and the type of, if we get this emission right, that we can drive this down into the 2050 mark, which is what most people are looking at right now for the reductions. And I know this author, Greg Katz, who does a book called Greening Our Built World, looking at the links between economics of carbon. Carbon right now is technically priced at about maybe $15 to $20 a ton, although that's like people buying carbon credits, so it's really, I don't know, you could argue that it's free right now in the United States. There's no penalty to spew carbon out onto the streets in Syracuse or New York. But what he's arguing, and I think his metrics are right, at certain prices, your reductions of energy, become significant value on a year-to-year basis to a landlord. If your rent is $30 a square foot per year, when carbon is priced at $50 a ton, and you have to either pay that via the building or your landlord, you could be seeing something up to 10% of that cost being the cost of the carbon. He's starting to link this. This is kind of, he's 2010, so it's all new stuff. You don't have to believe me, you're going to read about this. But I do believe that could be a significant penalty. If people start thinking their rents are going to go up by 10% or 20%, they may well start thinking about behavioral change to reduce their carbon footprints or looking at ways and strategies of reducing it. I think this is key to the market. Without a market for this, we're going to be struggling, honestly. This is a project that we did. Universities are great here because they are part of some climate initiatives, grouped climate initiatives. This is a project in New York City. And just looking at the ways of reductions in carbon that we're looking at from energy, electricity coefficient improvements, lighting, HVAC upgrades, all the way down to a 30% reduction here. So we're trying it and we're doing it, and this building's in construction right now. On to other infrastructure pieces and away from carbon and energy for a little bit, just in terms of water, but also in terms of, I'd say, naturalistic design that we see. Water management integration is key. There's a lot of areas of the world that water is an incredibly scarce commodity, maybe not in the Northeast, but we see it in California. Also, we see it a lot in certainly the Middle East. And we did a project in Saudi Arabia. This is not Saudi Arabia. This is California. This is actually right near our office in California. And I'm always amazed by these giant, just like swaths of Los Angeles that are just taken out by these I don't know, they're just, they're kind of these engineered, things in the middle of stormwater basins that, rarely fill up. And when they do fill up, it's pretty dangerous. But we had the same situation in Riyadh. Riyadh is a population of over 6 million in the city. And in the middle of the city, it had a wadi, which is basically a dry bed river that was actually being used and disused right in the middle of the city for trash dumping and all kinds of things. But it was essentially a wadi that funneled water down. And at a certain point in 20-year flood, this thing floods, like 20 feet, and it's a catastrophic event. What we did was we actually engineered through the pieces of the city, and this is a long-term project, but through the pieces of the city, a water management system to actually create a park instead of just doing giant culvert basins and smashing it through the city, because Riyadh didn't have a park. Riyadh has very little open space inside the city. It's choking itself to death right now because of the development going on. And this has become a newfound public space. And I think this is something that evolved over a period of years for us. It wasn't like we had an aha moment initially. And a number of other cities, South Korea and Seoul has a similar type of reclamation that's happened. But it's very interesting that we see these natural type of moves of dual use coming back again and again. And this is on, now that you have actually public use of these spaces, when it does flood, and we did have a 20-year event, this is all, it's all water all the way to sea, but then it recedes again and the park goes back to normal. So we've actually engineered a park that actually can be that natural system at the same time. Another theme is urban efficiency and renewal in cities. And we like this because we like to kind of get in the guts and grit of things. I was fortunate enough to be on the High Line with Diller Scofidio and field operations. And we won the competition in part by basically really playing up the fact that we don't want to rip this thing down. We don't want to do some giant repositioning of it. We actually want to treat it pretty much as an artifact that we just strip down and we put some simple things back into it. There were a number of teams that were going to put roofs over it and make it a building, and there was a big, like Parsons Brinkerhoff was saying, we'll just take it down after we win the competition. I mean, it was interesting. Really just treating this as something of a piece of urban fabric, and the result has been great. It's a great project. We're working hopefully on phase 3 right now. Even the developers are seeing the light, and it's been amazing in terms of generating all this value adjacent to it in terms of the tax dollar and tax-based revenue for New York City. And it also, you have all these found moments on it, and it's this sort of grittiness to the city, this urban regeneration and renewal, this reuse, which is, I'm proud of being part of those projects. There is also an energy piece to it, which is a little geeky about embodied energy and these types of things, about really maintaining that type of existing fabric. Not being a slave to it, but I think in this case, maintaining that existing fabric was a really strong strategy. This is another piece. It's a little bit more at building scale, but again about maintaining existing fabric. This is a transportation project we were involved in Germany, in Dresden. Foster and Partners were the architects on it. And this was after the fall of the wall, and 10 years into it, the station, the old Dresden station, was literally falling apart. And it had a roof structure on it that had to be removed because the old steel structures were about to literally collapse. But we came up with a system of, instead of putting a heavy roof back onto it, we could actually put a light roof back onto it, a thin fabric-coated roof, and that would actually save the existing steel structure. So instead of actually just destroying the whole station, starting from scratch, this is, to be honest with you, harder, but it actually saved the existing fabric of the station. And I think, again, this probably goes as close back to this type of linkage between where I started with lightweight structures and kind of touching the earth lightly. It's nice to see that there can be a connection between that type of technology and types of preservation. So these are the panels being hauled into place. These are the trusses that were preserved. They set up this crazy thing inside. You know, Germans, everything's precision and beautiful. But this thing like moves along, you know, as the trains are coming out, and it was the scaffolding. And this ends up being the kind of coating of the roof. And this is the roof inside. I mean, and architecturally, I think you get a completely different read on this thing, because now it's not some smoky old station roof. It's actually this roof with you know, incredible lightness on it. But yet the existing roof has been maintained. So you know, maybe a little bit of a stretch to link this in the High Line, but in our minds, they're similar strategies in terms of you know, urban renewal. So finally, on to some cities and to the broadest area that I'm doing. And I think this is where we really are struggling a bit. We're getting inundated with data on cities. And as at like a city scale now, you see all these IBM smart cities stuff. We know like tapping into that is absolutely crucial, but it's, and we're at the point where we know what we need to do with it, but it's still a struggle. And at a building scale, this is just showing, you know, we have, most of our buildings are done in Revit now. We have Revit catalogs. I mean, pretty soon in 20 years, you're just going to have a catalog of every building in the city. So, I mean, you're gonna have all this data at your fingertips. The question is now, like, what are we doing with the data? And again, I don't have an answer to it. I'm just saying as a theme, you know, this is a GSA project. This is a giant courthouse that I can't tell you how inefficient the energy was on this. Single pane glazing. They ramped up all the air conditioning systems, so the whole thing was super cooled, and then people brought in space heaters because they were too cold. So I don't know, and it's in Hawaii, which you can naturally ventilate to start with. So I don't know, you know, figure it out. But this shows all the mechanical and the ventilation systems that we model for the GSA, and you know, just again, kind of information overload. But what's coming out and what we're seeing are these types of benchmark and performance metrics that are becoming a lot more straightforward to read, and I think we'll be seeing more and more. I think buildings will be benchmarked. I think they'll be publicly accessible. I think you know, you'll be accessed on iPhones. You already can. And I think this is an area where we're interested in seeing it. And as a portfolio piece, this is interesting in terms of just browsing performance. We've been working with some universities, this is UC Davis, about looking at their portfolio buildings. Because as you start moving into all these portfolio buildings, how do you gather all of this data up and actually start to make informed decisions? In fact, and not a project I'll show here, but we're working with the World Bank on even something at a bigger area called a rapid assessment framework for cities. So we go in and establish energy benchmarks for cities that actually don't have it yet. They're normally second-tier cities like we just did Surabaya in Indonesia. We're doing Quito in Ecuador. Cities that actually don't have these types of metrics at their fingerprints. The World Bank is hiring us to go in for 3 weeks. We do the kind of calculations and give them some at least ideas of what's going on. But again, a lot of university owners are coming to us for this, and probably just getting off of data onto looking at carbon neutral now from a development point of view, not just a single building. This just shows, actually there's a development in China that we have been proposing, but looking at all of the systems and how they're all tied together. And this is where it starts getting really complicated, but also really satisfying. Because one of the things here in looking at a city is actually looking at the energy patterns and use of a city can be a strategy for reducing those energy patterns. Because certain energy patterns and program uses offset one another. Residential pieces tend to offset office, hotel, and retail. We can actually look at the coupling of program to actually offset energy use. So just building all office in one area of the city may not be a right strategy to get to net zero in that portion of a city. This developer in China said, as you do in China, I have 3 million square feet. You know, what should I build here? And if carbon restrictions are so significant to his thinking, because they're just in the planning phase right now, you know, we're talking to them about program mixes that may well help that carbon reduction strategy. And these are just some of the images from the architects that we're talking about. But you know, I show this graph. It's the same exact graph as on a building scale, but now we're coupled it all to these pieces. So we're going down in our normal strategy way and then looking for a renewable surcharge to kind of hit that. And we think that we can just about get there, starting to get there at a district scale now. And that's what's interesting to us. We're going from that building, that living building challenge piece, and we're working on some office buildings down in Oregon and other places that will hit, I'm sure, will hit living building challenge within the next 3 or 4 years, to starting to look at districts. And if you can start to look at healthcare and other kinds of areas, it's really about quality of health and quality of living, indoor air quality pieces that get measured. It's a tougher statistic than measuring salaries against productivity, as in an office building. How much more would you pay for that apartment, that has good indoor air quality if your kid has asthma? I don't know. I mean, that's not an easy thing to quantify. But the fact of the matter is health does have a cost. It has an absolute cost. There's no doubt about it. And I think and it's not just China, it's not just places that have smog. These are maps of asthma, noting that, the highest asthma cases in New York are of course in the lowest income neighborhoods with the worst buildings. I mean, it's just direct correlations. And how is that correlated to our healthcare problem in the United States? I mean, that's a direct correlation too. I mean, you do the math. It's not very difficult to figure out. The question is how we kind of tap into this. This is just at a city strategy piece, what we were talking about with Ken Smith, we've been designing for a park. This is an old Air Force base in California in an area of Irvine that's densifying pretty quickly. And thinking about in Irvine, again, for the next 50 years, as Irvine starts densifying, do they need these open spaces? And we used, there was nice elements of the park that actually repair some of the natural corridors from the mountains to the sea here and natural wildlife migration. These corridors will be open, will be not accessible to humans. So you can have, bobcats and other kinds of things coming in and out of there. But for the most of the park, the strategy of the park, again, was about public health. And we were going all the way back to the 18th, 19th century strategies about linking health into buildings, and these are some of the other aspects of it. So, I mean, just to end, thinking about it in terms of seeing the world, now I'm 20 years in, and I see all these things just really deeply linked together. I see cause and reaction all over the place in the strategies that we're developing for clients. It's not a repetitive thing. It's really interesting to me. It's really challenging. Sometimes I bang my head against the wall. Sometimes, we feel we've made real breakthroughs. But transport, waste, energy, water, it's all mixed together. And when you layer on these scales of buildings, infrastructure, cities, you kind of get a sense of how complex that problem is, but yet we're still, looking at these individual strategies for solving it. And I just want to say one thing about what you can do as students. Number one, you can get informed, you can read. I think it's pretty astonishing of some of the architects of, shall we say, my previous or the previous generation to that, how little their architecture was informed by energy and the environment. I think we see a lot more of it today in the architects of my generation we're working with, and I hope that trend will increase. But get informed. This is Greg Katz's book. This is Bill McDonough's book. This is Paul Hawkins. I mean, there's some great stuff out there. This is Ed Mazria of Architecture 2030, and he's got a great mission, which is to train architects by 2030 to get to zero emissions. And he might be, he's pushing very hard. Some might call him an evangelist, but he's an amazing character. And I mean, his argument that 60% of the energy reduction strategies can be dealt with through design, that architects are the key to the problem. Not the problem, but the problem solving. He's putting it out to you. And a lot of firms are taking up the challenge, benchmarking their buildings. It's right now some of the bigger firms, but it's going to happen. It's going to snowball, and we're already seeing that. And this is the strategies of getting down to carbon neutral. So get involved in this. This is real. If you're doing an internship, ask that company, what are you guys doing about this? This is not that difficult. A couple of phone calls to a client, you can pick out the energy numbers and get your EUIs on that building. Maybe the client's not using the building properly. Maybe they need to get somebody to renovate it or just to tune it up a little bit. I mean, this is important. This is important stuff, because if we don't, I mean, we're just going to flatline. Well, actually, not even flatline. I mean, he's arguing that we need to today get to 60%, and I don't think we're there. And then finally, think big. This is a big problem. I'm looking for people to work with. I really enjoy that type of collaboration. I'm not looking to just paste windmills on a building. These are really tough, integrated problems to solve. They have to be solved with economic fundamentals, no doubt in my mind. And sometimes the economic fundamentals don't work, and you just got to keep moving on and fight another day. But it's such an issue, it's such an important issue. I just want to make sure that I'm sort of getting it out there. This entering an era of scale, I really do believe this first wave of sort of quote-unquote sustainability, I think, has really come over us in the last 10 to 15 years, at least in the States and Europe. And I think that we, really looking to amplify that now and seeing what that next wave, we call it in our firm the third horizon. We call it that next horizon going up. That sort of hollowness of high tech is sort of there. There's nothing there anymore on that. We're looking for something that actually to grab onto. And I think this is the right time for everyone. So thank you. Sure.
Craig, thank you very much for a wonderful presentation. There is a lot to digest here, I guess. And I have a question that touches on a lot of things you mentioned, and that is addressing the issue of methodology. Design methodology, systems thinking, holistic thinking, a much wider approach towards design. Could you elaborate a little bit and you touched on this at several points, but how do you see the role of the architect changing, and how our students, when they get out, will be exposed to that? And how do you see the methodology and an interdisciplinary working mode having an impact on that?
I would say the role of the architect is going to be more important, actually. As an engineer, we are increasingly getting involved in other elements of buildings, like facades and lighting, that maybe traditionally were in the architect's realm. But engineering is not a discipline of integration. It's a discipline of siloed thinking. And I'm the first to admit that. I mean, I'm trained as an engineer to break down a problem into silos and solve it that way. And even though I think as a firm we try and rise above that to be as integrated as we can, we live in a world where people categorize us as engineers. So I think that architects you're getting the training that is important to think in a broader fashion. And I don't think that these problems are going to be solved in silos. I just don't. We have a saying that, one of our rules of engagement, silos don't work. They don't. I mean, they might solve an individual problem, but you put so many boundary conditions on a problem, it's easy to solve. You broaden it out. I really think that architects have to take up this charge and have to take up this mantle. And I would encourage everyone, if you think that architecture is somehow getting beaten down or shoehorned into a position, I don't think that at all. If anything, it needs to take on a much broader mantle of leadership. I mean, you think of some of the previous generation of architects, I personally don't think they've taken on a broad enough mantle of leadership in this area. I just don't. Certainly not American architects. Sorry. Don't quote me on that. Well, at least some people.
Anyone else before I have a quick question, which may be a little bit playing devil's advocate, maybe something else. But how much of the sort of political piece or the governmental piece do you think is important to the larger argument that you're making through the lecture, in that there is a call for architects to understand the systems and to work through them, but is there a kind of larger top-down push that perhaps architects and engineers should make to produce the regulation that would, in a way, solve many of the problems? You mentioned that if Boston has every building be silver LEED building, and then you lower the emission standards, then you're that you're absolutely creating a problem that architects and engineers can solve, because we know what the problem is then. I just wonder if you have any sort of...
Well, I think necessity is the mother of invention. So, you know, what's the town that was wiped out in Kansas, Greensboro, or was it Greensboro? And, you know, every building is now platinum in the new town. It's a rural town. This is a rural town that says, you know, we can't afford a, you know, platinum this. They've rebuilt in a methodology. BNIM, Ben Birkenbaugh, did it, and it's just a great example of integration, you know, at that level. So I don't know. I mean, necessities. They had no town left, so you know they had to do something, and the town actually thought that this was the most effective way of actually rebuilding. I would say from a regulation point of view, I think regulation is really important. I don't think without regulation on coal, you're not going to solve that problem. I mean, without you know, mercury type emissions restrictions, it's not going to be solved. I mean, if we don't get carbon caps, that's going to be a real problem. Because what I'm talking about in terms of what we call sort of the insurance policy with our clients, you know, carbon's priced one day, don't you want to be prepared? You know, if that just keeps getting put off, you know, it's like somebody else's problem. I mean, there's nothing like the immediacy of a problem to solve with a client to get everybody, you know, get really focused on it. And you know, the strategy there, we can do these jobs, and I actually don't think that the costs are unbearable. In fact, if you think about it, we're probably spending more, you know, doing the damage to our environment. You know, what's going to be the cost? Well, first of all, we can't reverse some of these things that we've done. So what are those costs? I don't know. FEMA's going out. FEMA's broke. Right? How many floods have happened in the last year alone in the United States, let alone the world? I mean, you know, all these patterns are happening. What are we paying for this? I totally believe that regulation is the way to go. To a point, I believe that policy is a huge important part, and it needs to be pushed. And it's a difficult political climate right now for regulation, but it's absolutely crucial.
I guess my question is sort of also about the sort of professional status of architects, of engineers, in their ability and their agency to advocate. In effect, if you have an opinion, let's say, about working at the scale of the projects that we each work on versus a kind of collective advocacy.
Well, I think there's some advocacy, but it's clearly not as well organized as the energy industry, so oil and gas industry. So I mean, that's tough actually. I don't really know what the answer is. I mean, there are certainly advocacy areas. We are looking at taking the mayor's 2030 plan in New York City and moving that to a broader framework so that it doesn't become like a political football in the next administration. You know, the mayor's 2030 plan in New York set up a whole series of cities around the world now called the C40 to establish energy reduction plans. London caught on in San Francisco, so it's now called the C40, and they meet every year. And it's very important. It's a very important, I think, benchmark. It's a fantastic plan. And we're working to try and, you know, make that plan not something of the political nature of what it is. I mean, it should actually be, you know, almost implemented in public advocacy. So it's maybe a slightly different, it's not like I'm going down to lobby government or something like that. I mean, probably get paid more. You know, this is a different kind of advocacy, but that's something we can contribute to, and we are. I think professionals should be. Okay. Oh, this one? I I think it should be absolutely integrated into the program. I don't see any reason why it couldn't be. I think there are simpler tools like Ecotech and other types of tools that are. We've done it. I've done it in individual studio classes where we've taught students of that nature. But I think there are, the tools are kind of raw right now, so maybe it's not so easy pickings. But Ecotech is definitely an area to start. But just to get familiar with it, Ecotech has a simple energy modeling package to it. And you could, just to have familiarity with it is important. Much more important to know that piece of software than structural engineering analysis package. I'll tell you that. Sorry. Yeah. I mean, I think it'll get better. Ed Mesria calls it the box. He wants like a box on somebody's laptop or their screen while they're designing, in Revit, so that like the EUI like changes while you're like making these moves. And I said to him, I think that might be going a little far, but he said, he's saying, well, we're gonna get there in a year. So I'm like, all right. But his job is to push. But I think it's really important. I think that awareness is really critical. And if you can get a studio that somehow plays with it, I think that's the most important part. It's not a homework assignment, and there's not a right answer. It's not 32 EUI is the best answer. It's like sometimes just play might end up in some interesting options. Does anyone? Mm-hmm.
All the time, but we know it's a bunch of issues. So as an engineering or when you deal with clients, how do you?
Well, all kinds of different ways, I guess. I mean, I think there are probably some good clients and some not so good clients. Our P&C clients very receptive to ideas. They want to see our return on investments and paybacks and things of that nature. But I don't know. I mean, I guess, how do we deal with it? We really try and look at the underlying life cycle cost analysis of a problem. But the fact of the matter is that sustainable strategies often don't pay back on straight life cycle cost analysis because of some of the things I just said. Because energy is cheap. Too cheap. You pay for energy because coal-burning plants pollute the air and people have to go into hospitals and you pay taxes for that. So how we got to get somehow some of those things linked back in a better way to make sure that that life cycle cost assessment can actually make some better sense to an owner. If you have 3 cents a kilowatt hour, I mean, virtually any renewable strategy that I'm going to do for a building is going to have a 15, 20-year payback. I mean, that's one of the reasons why you see some of these things in, say, Britain or Germany. A lot of the energy, the electricity energy in those areas comes from oil, which is more expensive, and they generally have higher energy rates. Something like, if our average energy rates might be 10 cents a kilowatt hour, 8 to 10 cents a kilowatt hour, there's probably 20 to 30. So you're seeing that. However, I would say we do a lot of end client user work with institutions, universities. We're doing work on a project in Riverdale in New York where the owner is very sensitive to investment. We look at the hurdle rates of what they need in terms of their investment dollars, and we outline. He's kind of a little bit of a fanatic, but he's got 14 buildings on his campus, and he wants to know as he does his energy upgrades, what they're going to pay back. And now they're a well-endowed school, so they have the money to do so, but they're not spending the money unwisely. So I don't know. It's hard to say. I mean, a lot of ESCOs are coming in now, energy service companies, because so much of our building fabric is inefficient. ESCOs can take big chunks of money, $100 million energy retrofits for schools in Syracuse, or in upstate New York, and do lots of energy retrofits around that 100 million. And they can basically, repair windows, leaky windows and things like that, and get pretty much energy savings from those and actually bank the money, and there's a strong investment tie into that. I think the ESCO market's booming right now in the States. It's like $9 billion, it's gonna go to $50 billion, but it's chipping away at that really inefficient piece of the marketplace and then going downwards. So I don't know, hard to say. As you get into the grittiness of cities, it's really hard for an ESCO to work because everything is so interconnected and so small scale that they don't want to even go near cities. And that's actually, in a way, where some of the real problem is in the denser cities. So it's probably not a great answer to your question. A lot of different strategies actually out there but I think it's really crucial. We do life cycle cost analysis, and we try and improve the payback and the hurdle rates on these things. Sorry. Okay. Thanks.